So we're just going to be doing a putting this all together word problem. This is how to use, this is more of a thinking and inquiry type question. And it's how to use the information that you're given to determine the domain and range of a function. And this is something that's a little bit more complicated so that we can, I'm just going to show you step by step how to solve this if you're given a question like this. So with word problems, we always want to kind of put whatever we're given in some sort of mathematical terms. When we're doing problems with functions and trying to find domain and range, it's usually just easier to draw a diagram because then you can see the function itself better, right? So I'm just going to read you the problem now. So the problem says that a window washer is washing a window 800 meters off the ground. His partner is working on the building next to him. He throws a tool to his partner by tossing it in a parabolic shape. So we already know, if this is parabolic shape, that this is going to be a quadratic function, 2 meters into the air. The tool misses his partner and lands on the ground after 3 seconds. Determine the range of the function, domain and range. So we're finding both domain and range. That means we're looking for all possible x values as well as all possible y values. Okay, so first things first, when you're given a function like this or given a problem like this, I like to draw it out. So I like to make myself a little mini diagram. So I'm going to make my little, I'm going to make this on a sort of plane, right? So it's always good to write it on a parabolic or on a Cartesian plane. That's just like in kind of like graph format, right? So these are going to be all my positive y's. This is going to be my negative y's. This is going to be my positive infinities, and that's going to be my negative infinities over here, right? I just don't have enough space to write it down right now. So I'm just going to leave it at positive infinity. First things first, we know that this is the building, and it's about 800 meters off the ground. Sorry. Just going to draw this in a little bit nicer. So this is my building. It's about 800 meters off the ground, right? So I'm just going to write 800 right here. Just going to move this over a little bit so that you can see that a little bit better, right? Just going to draw in 800 right here. So these are all my negative x's. Negative infinity. Okay, so that's 800 meters off the ground. And then my second building, I can just draw it anywhere I really want. I'm just going to draw it over here. This is my second building, right? The building can be however tall we want it to be. We just need to know that the window guy is here. So, and this is going to be my little other building, and my little window guy is going to be here, right? So I'm just going to draw in my function with a different color. That's kind of just my diagram. So we know that he tosses it from here, right? Tosses it from here. This is going to be x is equal to, so in this function, we're measuring it in terms of time because we know after 3 seconds, it's going to be time. And we know that we're measuring the height of the tool, right? Because we're starting off at 800 meters. So time is going to be the independent variable. Why is that? Because time is always the independent variable. It's not the thing that, it's the thing that determines where everything else is. Time is always going to be the independent variable. So that's going to be my x's right here. That's going to be time. Height is going to be my dependent variable, right? So this is going to be my y, this is going to be my x, right? So that's first things first. Draw your diagram out. So it starts off here at time 0. We know that that's when he starts to throw it, right? He throws it up into the air. It misses this guy, and it comes and lands on the ground here, right? At this time, it's going to be, so that's clear. This time that it lands, he says, is 3 seconds. Okay, and then he says that it's 2 meters higher than 800. So I'm going to go up to 802, right? I'm just going to add 2 meters to 800 because that's where my maximum is going to be. So now that I'm looking at this function, I'm going to try to determine my domain and range. So domain is, like I said, all possible x's. Therefore, all possible times. Can't have a negative time, so time has to be greater than 0, right? Also, it hits the ground. Once it hits the ground, it's not going any further. So, time also has to be less than 3. Less than 3. Because at that point, the ball just lands, or whatever, the tool just lands on the ground, and it's not going to go any further. Right? So that means that my domain must be between 0 and 3. Therefore, I'm just going to write it in. X, or if you want to be more specific, t, such that t is greater than 0, less than 3. T is an element of all real numbers. If you wrote this as x, I would accept this too. So if you wrote this as x, such that x is less than 0, less than 3, x is an element of all real numbers, I would accept that. But if you had actually labeled this time, it would be incorrect if you had written it like that. So just for your future purposes and in your classes, I would suggest getting in the practice of writing the variable as what you had labeled it on the graph. Okay, so we found the domain. We now want to find the range. The range of this function has to be between its maximum here and 0, because you can't have a negative height, right? So your range is going to be between 0, right? Because it has to be greater than 0. And it's 802 because he started off at 800 meters because that's how high off the building it is. And then he tossed it 2 meters into the air. So this toss is important because it tossed it 2 meters into the air, which means that the maximum height wasn't 800. It was actually 802 because that's as high as it got. And then it turned around and it came down. So a range has to be between 0 and 802 meters. Therefore, the range is going to be h, such that it's greater than or equal to 0 and less than or equal to 802. Y, h is an element of all real numbers. So this is just saying that the height is greater than 0 but less than 802, which makes sense because it turns around at 802. Height is an element of all real numbers. Again, if you had written this as y such that y is greater than 0 but less than 802, I would have accepted that as well. It's however you choose to write it. I personally prefer this way because that means that you actually understand which variables you're working with. And that is how you solve that problem. Thank you for watching.